Oh, sorry, I didn't realize I had started already. Oh, maybe you want to see. I found some gold. There's gold in them there mines. All right. This is part 4, Holes Anatomy, chapter 9. I think it's part 4. And recently on the in the social sphere, I've been getting some flack, especially on Twitter, on my Twitter feed. Um, and people have been saying that video that I created with the muscle song, they're saying that wasn't really me. And I wanted to finally set the record straight and just come out and be honest and say that it was me. And really, truly, those are my muscles. And I want to show you how much work I put in. You can see how much weight I'm lifting here. This is really, truly a picture of me working out, building those muscles. And that's what it takes. There's no steroids at all involved in this image. It truly was me, you can tell. So I just wanted to clarify that and make sure you're clear on that. So let's move on with this. So how was I lifting those giant muscles and making my arms move? Well, the muscle's attached to a bone, and by shortening, when the muscle shortens, it pulls the bone with it, and that causes the arm or the joint or whatever it is we're talking about here to move. Okay. Now the attachments are origins and insertions. The origin is where it's attached to an immovable bone, so we have the origin up here for the biceps, and the insertion is the attachment on the movable bone. So this bone is going to move up. This is the insertion. This is the origin. All right, simple enough. Now, those of you that have taken physics, this will be a lot easier. This is just to give you some understanding, some basics of how all these joints work, and they're basically like levers. Okay, there's the bar itself, the rigid bar, which is shown here. Okay, and that rigid bar sits on a fulcrum, as it's called. That's the point that's going to where the bar is going to move. That is the joint itself, if you like. And then the object itself that's going to be moving, okay, against the resistance, that's the weight. And then you have a force that's applied, and that's the muscles. So all these things are basics of a lever in physics, and they apply also in a system here. And you can see that being the case here with the biceps muscle. Here's the radius and ulna, and then the humerus, and here's the biceps brachii. And you can see it working there. Both the biceps and here's the triceps. Okay, moving on to more important things. When you use your muscles and work out, especially with resistance, you're going to increase muscle size. Okay, you're going to increase muscle strength because, of course, the bigger the size of the muscle, the stronger it is because you can recruit more sarcomeres. The muscle's efficiency, so it gets better at using oxygen and using ATP, so it doesn't waste, if you like, as much, and therefore you're able to, say, exercise for longer on the same amount. Your heart becomes more efficient as well, and so on. And then the muscle itself becomes more fatigue resistant. So you don't get tired as fast, you can run longer distances, and so on, of course. That's all pretty straightforward and obvious. Okay. On this one, I wanted to bring in a guest here for a second, so I'm going to go get her, and I'll be back. All right, so I brought my special guest here, and she's going to help us out. Yo, dog, stop spazzing. Yo, dog. All right. Let's learn about types of contractions. Say hi, Bella. Oh, she's knocking over the sound here. All right, this is Bella. She's my big puppy, and she's going to talk to you about isotonic contractions. Isotonic contractions are when they change length. So this is an isotonic contraction. That's isotonic, okay? More specifically, concentric is a type of isotonic contraction where the muscle shortens, of course. So this, again, concentric and isotonic. Now, eccentric is this, where the muscle gets longer. This muscle in the forearm is elongating, and therefore it's an eccentric contraction, and you'll learn later that this is the primary cause of delayed muscle soreness. And then last one, we have isometric, which you know when the muscle contracts but does not change. So right now Bella's flexing, you can't see, but there's no movement in any of her joints, and so it's an isometric contraction. And you can see them also here, showing all those different three items. Movement, either direction, and then no movement. And say bye to Bella, she's too heavy. Oh, blowing things up. Okay. All right, types of muscle fibers. Slow twitch, fast twitch. So slow twitch fibers are Oxidative, meaning they use cellular respiration. They need oxygen to do it. They're sort of your long-term. They last a long time. They're very red. This is your red meat, if you like. And the redness comes from myoglobin. It's a protein that carries oxygen in the muscle, very similar to hemoglobin, but it's red. It has a very good blood supply, and it's very resistant to fatigue. So you long-distance runners, you have a lot of slow-twitch muscle fibers. Okay. Then you have, I'll go to the opposite extreme. You have fast-twitch glycolytic fibers. These are anaerobic fibers. They're very quick to react. They're white. This is your white meat, if you like, because they have less myoglobin, so they don't have as much oxygen. They don't use oxygen. They just do glycolysis or anaerobic fermentation. And because they don't have a lot of oxygen and therefore a lot of ATP, they fatigue really quickly. But they also are able to get initial storage, initial levels of ATP really fast. So they can flex and fire really quickly. These are your fast twitch, but they fatigue really fast. And then there's an in-between, these intermediate fibers called fast twitch, but they're fatigue resistant. Okay, they do use oxidative means, and again that just means using oxygen to do respiration, where you make a whole ton of ATP in the cell. These are pink. Okay, an intermediate amount of myoglobin, and they are somewhat resistant to fatigue. So 3 different types of muscle fibers. Every individual has differing amounts of those, and you can also manipulate those based on how you train. So for me, I'm a sprinter, and I hate running long distances. If I run a mile, I might die, but that doesn't mean that I couldn't. And over time, if I trained myself and built up and ran long distances, then I could convert some of my fast twitch muscles into slower twitch muscles, and the percentages would change, and therefore I'd be able to run longer distance. I wouldn't fatigue as quickly. Okay, and this is giving you some idea, okay, of tension. Fast twitch fibers can contract really fast, but then they fatigue very quickly, and slow twitch contract more slowly, but they fatigue less quickly. And this is another chart. What I'd like you to do here is identify what's A, what's B, what's C, and in class we'll answer these for you. Which one is fast twitch glycolytic? Which one is fast twitch fatigue resistant? And which one is slow twitch? All those 3, A, B, C, you identify them. Once again, as you know, it sucks to get old. I can tell you from experience, although I'm not old, don't say that. What happens when you get old? So myoglobin, that's the stuff that makes your muscles red and carries oxygen for you. Levels decrease, ATP levels decrease, and with that creatine phosphate, remember that's the thing that helps to recharge the ATP initially, those decline. So your muscles aren't going to work as well, they're not going to be able to run for as long, and so on. At about 80, you have about half your muscle mass. It's largely atrophied because you haven't used it and so on, unless you're that 80-year-old guy who works out all day long and he's really ripped. I've seen him on TV. It's actually my dad. And then your muscle cells and connective tissue are going to replace the muscles, so you start to get fatter, less muscle, and so on. And you can exercise to help maintain these things, but it gets harder and harder and harder. As you get older, you're simply going to get fatter, or you have to work out more to not get fat. Now, what types of things can happen when these systems go wrong? Well, there's one called myasthenia gravis, which is actually an autoimmune disorder. Your immune system attacks the receptors for acetylcholine on your muscle cells. Remember, acetylcholine is a neurotransmitter that goes from a neuron across the synapse of the neuromuscular junction and binds to the muscle cells. These receptors are attacked, and as a result, acetylcholine can't activate your muscles, and your muscles start to become weakened, and they fatigue. You have difficulty swallowing and chewing. You have difficulty breathing. So some possible treatments are to increase your acetylcholine levels, to try to remove your thymus gland, which is just above your heart, because your thymus gland plays a role in maturation of immune system cells, and then also immunosuppressant drugs and giving you antibodies. So all these things trying against myasthenia gravis. One of the characteristic things with myasthenia gravis is actually droopy eyelids. It's one of the first signs that you see. Other types of diseases, botulism, you might have heard before. We have some fruit trees, and when we were canning some of the fruit, some of the peaches, to make peach jam, which was disgusting, by the way, you have to prepare the cans, the bottles, in a proper way, because if you don't seal them properly and sterilize them, they can grow the botulism toxin. botulinum, and as a result, if you eat it, you can get botulism, which is super harmful, super bad. It's a blocker of the release of acetylcholine into the neuromuscular junction, which, just like we saw with myasthenia gravis, no acetylcholine is going to mean paralysis, essentially. So your body very quickly becomes paralyzed, including your respiratory muscles, and you die. Delayed onset muscle soreness, DOMS as it's called. Now this is different from acute muscle soreness, that pain you feel right after you've worked out, like, holy crap, my muscles hurt. This is 24 hours, 2-3 days after you've worked out, where you feel sore. Okay, and there's some hypotheses as to what the cause of this is. It used to be thought that buildup of lactic acid from anaerobic fermentation caused this delayed onset muscle soreness, but we now know that it is not the cause. At least the evidence doesn't show towards that. We now think that it's damage or little micro tears in the myofilaments, actin and myosin, and also the fascia that connects the muscles. Little tears in those cause pain and damage to the area that has to be repaired, and that's delayed onset muscle soreness. And CPK here stands for creatinine phosphokinase, which is, just to give you an idea, it's the enzyme that takes the phosphate off of ATP and puts it onto creatine, to make it creatine phosphocreatine or creatine phosphate, CP, like we've talked about. Typically CPK stands for creatinine phosphokinase. There's a few different names, but that's typically a supplement that people can take as well. And then lastly, that DOMS is actually caused by eccentric movements, which are lengthening contractions. So think, as actin and myosin are sliding across each other to shorten, lengthening contractions, the muscle is trying to shorten, but your limb is the muscle's trying to lengthen, and as a result, while this shortening happens, these are being pulled, and so you're causing breakages in a lot of these actin and myosin fibers. So DOMS is primarily caused by eccentric movements as opposed to concentric movements. Okay, and on that note, we are done. Thank you for playing today. Wow.